This is lesson 97 for Honors Geometry. It is due Monday the 11th, and it is over concentric circles. Concentric circles, that just means they have the same center. So, for example, if I draw a circle here and a circle inside of it and show that there's just one center, then those are concentric circles. If I draw a circle and then draw another circle inside of it and I put that this center is here and this center is here, these are not concentric circles. So concentric have the same center, these are not concentric. So you'll have to be able to identify whether it's concentric or non-concentric. Pretty easy to do. Then you'll have to write some equations knowing that they're concentric circles. So let's see, the center is -2, 3. And I've got circle A and circle B. Circle A has a radius of 4. Circle B has a radius of 6. But they are concentric. So if they're concentric, that means they have the same center. That means the center for A is -2, 3. The center for B is -2, 3. So to write the equation for A, it would be x plus 2 all squared. Some of you are still forgetting to change your signs. X minus 3 all squared equals 16 because I square the 4. That's for circle A. Circle B, the first part of the equation looks exactly the same because they have the same center, and then it would be 36 because I square the 6 and get 36. So that's how you deal with circles having the same center. Sometimes you might be given a graph. Let me see if I can draw this halfway decent. And so you have a circle here. There's that circle. Wow. Yeah. And then you've got a bigger circle, but it has the same center. So you would count for the center. So let's say the center on this one is 2, 2. You would count for the center. Or you would graph for the center. You would find the coordinate for that point. Okay, right 2 up 2. Then you would count for your radius. So this is 2 boxes because I'm right 2. So this radius is 2. We'll say this radius is 5 maybe if I go all the way up for the big one. It's 5. So then if they're concentric circles, that means the smaller circle would be x minus 2 all squared because I changed the sign when I plug it in. Y minus 2 all squared equals 4 because I square the 2. And then x minus 2 all squared plus y minus 2 all squared. Since they're concentric circles, the first part of the equation looks the same. And then this would be 25 because we square it. Okay? Now, concentric circles, when they are concentric, they make what's called an annulus. And the biggest thing you have to do with an annulus is find the area. Okay? So it's like the donut. So if this is 6 centimeters, and then this piece is 3 centimeters, this is your annulus right here. So that's why I said it's like the donut. The hole's been taken out. There's a hole right there. That's the annulus, okay? So you want to find the area of the annulus. The area of the annulus is big circle minus small circle. That's all you do. It's big minus small. So the biggest circle here is not radius 3. The biggest circle here is radius 9 because 6 plus 3 is 9. So area of a circle, and the majority of the time they want you to give exact, which is in terms of pi. So the biggest circle would be 9 squared pi. The smaller circle would be 6 squared pi. So I'd have 81 pi minus 36 pi. And then whatever 81 minus 36 is, 45 pi. And it's centimeters squared because it's area. Okay. Now, I was just looking back at the book, and okay, no, it's right. They just did it way long, and you don't have to. Just find the area of the big one in terms of pi, find the area of the little one in terms of pi, 45 pi centimeters squared, and you subtract them every time. That's how you find the area of the annulus. So let's see. Let's try another one just to show you that, area of the annulus. So I've got concentric circles. That's the only thing that can make this annulus. This is 8. This is 5. This is 8 inches and 5 inches. So if I want area, pi r squared, so I write my area formula. And we're going to be asked for exact. They usually ask for exact, so that means you leave it in terms of pi. So then my big circle is 13 because 8 plus 5 is 13. So it'd be 13 squared pi minus 8 squared pi because we want biggest circle minus smallest circle. So it's like the donut. You're taking out the donut hole. Here's the hole. Here's the donut hole. You're taking it out of the donut and you're leaving the rest of the donut. Okay? So this would be 169 pi minus 64 pi. So 169 pi minus 64 pi would leave you 105 pi inches squared. And that is lesson 97. Not much to it, but you do need to know how to find the area of the annulus and what the annulus is. So now let me make the assignment. Let's see. You're going to do the warm-up. Yeah, it is on page 630. Not anything crazy on the warm-up. You're going to do practice. You're not going to do all the practice. You're only going to do A through C. Then on the lesson, you're doing 1 through 7, 9, 13, 15, 17, 20, 22, and 24 through 30. Again, this is due the 11th. It's due this coming Monday, the 11th. So you have a full week. You have one assignment this week to copy notes and then do this. Okay? Copy notes and then do this lesson. So let me see if there's any I need to say anything about. Remember, don't graph. Oh, on number 2, when it says you're going over the y equals x line, that means you take your ordered pairs and you just flip the x and the y. So don't graph. Do not 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 graph. Then on number 13, we want the exact area of an annulus between two concentric circles, one with the radius 15 and one with the radius 2. So let me show you what that looks like. That means they've given you the radius of the big circle is 15, and they've given you the radius of the small circle, which is 2. So it's not 17. Don't do a 17. It's going to be 15 squared pi minus 2 squared pi. So be careful with that one. Well, I mean, you've got to be careful with it because I just showed you how to do it. But that's what it would look like. This whole thing is 15. You know, we saw the ones where we had to add to get it because they gave us the radius of the inside circle and then just this part of it. You know, just this part of it. But here they give the whole radius of 15 and then the inner circle has a radius of 2. Then on 5, you're wanting the horizontal component, so that's your cosine. That's the magnitude times the cosine of the angle. They give you the magnitude is 30, your angle is 60, so it's magnitude times cosine of the angle on number 5 to get that horizontal load. Then on number 6, let's see, you've got passengers in a hot air balloon see a playground and an angle of depression. So angle of depression is sky down. So this is 16. They are 150 meters above. Here's the playground that they see. We want their distance. Later, they see at an angle of elevation of 36. It's still 150. This is still the playground. And then have they moved closer or farther from the balloon? So that's the way those two set up. So you just need to, oh, I want to see the distances. I want to see the distances on these to show if they've moved closer or farther from the balloon. Okay. Then number 7 is just a simple, actually number 7 is not. Number 7, I need to show you on number 7. Because it says the figure is made up of concentric circles. So it's got these concentric circles. This is 12. This piece is 10. Let's see. If a coin is randomly dropped onto the figure, what is the probability it will land on the shaded region? So probability is part to total. So we want it to land on the shaded region. We want it to land on this shaded region. So we need to find the total, which is pi r squared. The total would be 22 squared pi, because 10 plus 12 is 22. That's the total. Then the annulus, because that's where we want it to land, the annulus would be 22 squared pi minus 12 squared pi. Okay, because we've got to take that out for the annulus. So this is 2, that is not 2. This is 484 pi minus 144 pi, which would give us 340 pi. So this is 340 pi. Now I've already shown you what 22 squared pi is. So you do that and then make sure you reduce. Make sure you have a reduced fraction for that probability. So that's number 7. Then number 9. Oh, that trapezoid has all congruent sides. So just find the perimeter. It's just adding up the outside. Then you skipped to number 13. Number 13 is just dilating by a factor of 3 and then finding the new perimeter. Not a big deal. Then you skip to 15, finding the area of the annulus. Already talked about that. Then looking at 17. Let me draw 17 and talk about something on 17. This is 132. This is theta 2. This is 17. These are congruent. And this is theta 1. Okay, so we want to find theta 1 and theta 2 on this. What you could do, yeah, that's what I'm missing, 54. So what I would suggest on this, starting out to find theta 1, is use law of sines. And then, since these two are congruent, once you get theta 1, you can put it here and then subtract it from 180 and get theta 2. So you're going to do law of sines, so we'll put sine of theta 1 over 132, because that's opposite, equals sine of 17 over 54. Okay, sine of 17 over 54, because they're opposites. So I'm looking at the biggest triangle. I'm ignoring the two little triangles. I'm looking at the biggest triangle. Sine 17 over 54, sine theta 1 over 132. So that means sine of theta 1 is 132 sine 17 over 54. So that means you have to do the inverse sine of 132 sine 17 over 54. And again, once you find that theta 1, it'll go here and here, and then do 180 minus theta 1 to get theta 2. Okay, so that should help you on number 17. Number 20. On number 20, you have a rectangle that has a diagonal of 13 and one side length is 5, and you want the area. Area is length times width. So find that. A squared plus B squared equals C squared, something like that. That was 20, not 13. That's number 20. Then you skip to 22, which is setting up. A map has a scale factor of 1 to 250. If a map represents a community center by a square with an area of 100 square centimeters, what is the actual area of the community? So that means you have to do 1 over 250 squared equals 100 over x, because we want actual. So this is map. Yeah, this is map to actual. Since you're talking about area, you've got to square it. Okay, so you'd have 1 over whatever 250 squared is, and then solve the proportion. Then you're doing 24 through 30. 24, you're just writing equations of the concentric circles. Looks like they give you the graph, so they give you the center, it's 5, -4, and then you've got to count for the radius. How are the equations alike? How are they different? Well, their centers are the same, their radius are different. That's all you'd put. 25 is just changing the equation of the circle. On 26, that is a rhombus, and they're asking you what NSM is, which is where your diagonals are. So you need to remember about the diagonals and what kind of angle they make. Converse is where, on 27, converse is where you flip the if and the then. 28, you're just setting up equal stuff. That's not a big deal. Well, they're similar, so set up a proportion. 29, remember on an inscribed angle. So we're given that we have an arc that measures 96, and the measure of its inscribed angle is 2x plus 3. Well, that 2x plus 3 equals half of 96. So you take 2x plus 3 and set it equal to half of 96 and find x. Then on 30, it says use the Venn diagram to write the conditional statement. You've got cardinals inside flying birds. Cardinals inside flying birds. So you do something like, if a bird is a cardinal, then it can fly. Or if a bird is a cardinal, then it's a flying bird. Something like that. Okay, so again, this is lesson 97. It's due this Monday, the 11th, so you've got all week to take the notes and do this lesson. Make sure you finish the ones I've started for you.